Slope fields. What is a slope field? First off, you need to know, if you don't already, that derivative equals slope. When you find the derivative of a point on a graph, you are finding its slope. What makes slope fields useful? They're used to graph functions that are sometimes underivable. There's no need to know how to derive a function, which makes it very cool and easy, and they show the derivative of a function at several points. Example 1. Say we are trying to create the slope field graph for the function dy over dx is equal to 2x plus y. The first step would be to use a coordinate graph as shown to plot the slope of several points to see how the graph of the function would look. This is done by directly plugging in the x and y values into the equation. So for the point 1, 1, you would plug in the values to the equation and get 2 times 1 plus 1 equals 3. Therefore, the slope at the point 1, 1 is 3. For the next point 1, 2, you would again plug in the values into the equation and get 2 times 1 plus 2 is 4. Therefore, the slope at the point 1, 2 is 4. If you were to continue this trend and get all the slopes for the points on the graph, you would get a graph that looks like this. This graph shows you the general trend that the function takes, allowing you to see the big picture. Remember, if dy over dx is greater than 0, your line is increasing. If dy over dx is less than 0, your line is decreasing, going down. If dy over d of x is equal to 0, you have a horizontal line with a slope of 0. If dy over dx is 0 over 0, you have a vertical line whose slope is undefined. In conclusion, let's recap. What makes slope fields useful? With simple math, you are able to generate the graph of a derivative function. Also, the various slopes come together to show a trend of what the graph would look like. The end.